Good evening, you pre-AP, pre-Cal Bearcats. This is your pre-assessment part 1, and we're going to get started right away. This is on page 159 and 160. This is the first part of your pre-assessment, and this is problem number 16. They ask you to solve, or they ask you to use long division to find the quotient. So here we go. So notice in the dividend that you've got x to the fifth, and you don't have a fourth or a third or a squared or an x term. So we're going to leave zeros in our long division to hold the place of those values. So here we go. So I'm going to, under the house, old-fashioned division, I'm going to have x to the fifth. I'm going to say plus 0 x to the fourth plus 0 x cubed plus 0 x squared plus 0 x and then plus 7. And we're going to do long division, and we're going to divide by x cubed minus 1. All right, x cubed times what gives me x to the fifth? That would be x squared. And then multiply just like old-fashioned division. X squared and x cubed give me x to the fifth. X squared times negative 1 gives me a negative x squared. I'm going to line it up, negative x squared. Now remember, it's division, so you're really subtracting everything on this row. So this is going to become a negative, and subtracting a negative becomes a positive. Draw your line, like add down. These should always cancel out. You have no x to the fourth, you have no x cubed, but you have 1x squared. And you have no x's, but you have plus 7. And then you're going to stop because this is your remainder. And you know it's the remainder because x cubed times something, we'd have to use a fraction. You can't use, you can't continue. It's a smaller degree than what your divisor was. All right, so this is the answer, and you're going to write your answer this way to get all your points. You're going to write x squared, and since x squared over here is positive, you're going to say plus, and that's going to become the numerator of the fractional remainder. X squared plus 7 over x cubed minus 1. And that's how we write our answer, and that would be your first problem. Okay, go Bearcats. Move on to the second problem. Next problem is problem number 19 off those same pages. Your problem. Okay, so our problem is here in front of us, and we're asked to use synthetic division this time. This time we have an x cubed, an x squared, an x, and a constant, so we do not have to worry about zeros as placeholders. We're going to set up our synthetic division, and we have 3, and then negative 17, positive 15, negative 25, and synthetic division, and we're going to divide by, we take our divisor, and it's what the solution would be, which would be 5. So we're going to divide by our solution, our x-intercept. And we should get a 0 if that is in fact an x-intercept. So we're going to bring down the 3, and 3 times 5 is 15. 15 plus negative 17 is negative 2. Negative 2 times 5 is negative 10. And if you need to write those in, you can. By the way, if you need to write 15 in there and negative 10 in there, you can do that. That would be positive 5, and of course 5 times 5 is 25. 25 and negative 25 is 0. Woohoo! We got a 0, which is what we were expecting, so that's a really good thing. So our long division then would be written as such. We reduced our polynomial by a degree. It is not a cube anymore. This would be left with an x, with a quadratic, x squared, so we would have 3x squared minus 2x plus 5, and that would be our final answer. Way to go, Bearcats. Okay, the next two problems are a little lengthy and a little tedious. They're not necessarily difficult, but they are tedious, and you're going to have to be careful and neat in your work so that you don't make careless mistakes. We're going to write this in the form f of x equals x minus h times q of x. That's going to be our factor after we divide and find the remainder using the value that they give us for k. So that's how, and this is, sorry, this is not h, this should be k. Alright, so we can write this factor first. Let's go ahead and do that. And our final answer we're going to write up here at the top so that I don't run out of space on my little thing. So my final answer up here will be up here. And since they want it to be f of x equals x minus k, we're going to come over here and we're going to go x minus k. K is 1 minus the square root of 3. We're going to distribute the negative, and you're going to get x minus 1 plus the square root of 3. And that'll be our first factor. So this factor right here, I'm just going to kind of draw a little arrow up here, would be x minus 1 plus, the square root of 3. It's kind of messy. Plus the square root of 3. That's our first factor. Then we'll have another factor, and then we'll have a remainder if we have one, or it could be 0. All right, let's go on to synthetic division and divide synthetically. We're going to be using negative 4, 6, 12, and 4, and we're going to divide synthetically by our k value, which is 1 minus the square root of 3. And again, this is just tedious right here. It is not necessarily difficult. You're going to have to be really careful not to make careless mistakes. So of course we bring down the 4, and you have a negative 4. I'm going to draw a little line this time to give us a little bit of room to write, since these are complicated numbers. Alright, so we have negative 4 times 1 minus 3. I'm going to do all of my work for that over here to the side so you can see what that is. So that's negative 4 times 1 minus the square root of 3. That would be negative 4 plus 4 square roots of 3. So that's what would go here. So it would be negative 4 plus 4 square roots of 3. When I add that to 6, I would get positive 2 plus 4 square roots of 3. Now, I've got to multiply this by this. So I'm going to go over here to the side again and work on that. So I'm going to have 1 minus the square root of 3 times 2 plus 4 roots of 3. And this is where it gets tedious. You have to be very careful. So I'm just foiling. So you have 1 times 2 is 2. And 1 times 4 square root of 3 is positive 4 square roots of 3. And then underneath, or going the second round, you have negative square roots of 3 times 2, so that's a negative 2 square roots of 3. And then you have negative square roots of 3 times 4 square roots of 3. That's going to be a negative 4, and the square root of 3 times the square root of 3 is actually 3, and negative 4 times 3 would make that a negative 12. And then we're going to combine like terms and put it in a plus bi form. So you don't have any imaginary numbers, but just a complex number. So we're going to have 12 and 2, which would be 14. Oh, minus 12, sorry. It's a negative 12. Be really careful. Might as well write that up there. Negative 12 and positive 2 would be a negative 10. And then 4 square roots of 3 and a negative 2 square roots of 3 is a positive 2 square roots of 3. So negative 10 plus 2 square roots of 3. And that's what's going to go right here. So negative 10 plus 2 square roots of 3. Negative 10 and positive 12 is a positive 2 plus 2 square roots of 3. Alright, remember we're hopefully finding a 0 here in a minute. So now we have to multiply this by this. Again, off to the side, I'm going to have 1 minus the square root of 3 times 2 plus 2 roots of 3. And FOIL again. 1 times 2 is 2, and 1 times positive 2 square roots of 3 is positive 2 square roots of 3. Negative square root of 3 times 2 is negative 2 square roots of 3. Ah, those are going to cancel. That's a really good thing. And now here again, we have a negative square root of 3 times a positive 2 square roots of 3. That's a negative 2. Square root of 3 times the square root of 3 is 3. So when we do 2 times negative 2 times 3, that we get a negative 6. Again, combine our terms. Negative 6 and a positive 2 is a negative 4. And then the 2 square roots of 3 and the negative 2 square roots of 3 cancel. So we have a negative 4 and we get a 0. Woohoo! Go Bearcats. That's a really big problem there. Alright, so remember it was a cubic and now it's a quadratic, and we're going to write that. So you would write it as negative 4x squared, and you would write it plus, since 2 is positive, plus 2 plus 4 square roots of 3. Oh, that was kind of messy, sorry. So parentheses, 2 plus 4 square roots of 3, close the parentheses, and an x on the outside. So that's the coefficient in front of x. And then we would write it as plus the constant, which is 2 plus 2 square roots of 3. And that right now becomes our other factor. So we're going to go up the top and write that. So we would have minus 4x square roots of 2 plus parentheses 2 plus 4 square roots of 3x plus parentheses 2 plus 2 square roots of 3. Those are our factors. Plus the remainder, remember we want plus r. Our remainder was 0, so plus 0. And then we wanted to write our function notation again. So when we have f of, this is part of our answer, and our value was f of 1, f of 1 minus the square root of 3, which is what we were given originally. When we plug that into our equation, we found that the output was 0 because that is an x-intercept. Alright, so up here, kind of messy, but all of this then would be what your answer would look like. Go Bearcats. Alright, let's do another one of those because I think we need a little more practice. Alright, this is problem 44 we have here. Our k value is 2 plus the square root of 2. So in a minute we're going to evaluate for 2 plus the square root of 2 and find an output to go with that. We're also going to do a complete factorization of this problem. So we know that this is a factor if in fact it is, when we put in the equation it comes out to be 0. We're going to anticipate that happening. So if this is a factor and this is an x value, then it would be x minus parentheses 2 plus the square root of 2. And if we simplified, you would get x minus 2 minus the square root of 2. X minus 2 minus the square root of 2. That would be our first factor. So I'm going to come up here at the top where we're writing our answer and write that. So x minus 2 minus the square root of 2. That's our first factor. Now we're going to find the other one by synthetic division. So again, we're going to start with, we have a negative 3, a positive 8, a positive 10, a negative 8. And we're going to synthetically divide by 2 plus 2, 2 plus the square root of 2. Again, it's more tedious than anything else. I'm going to try to clean this up just a little. There we go. There we go. So we're going to bring down our first term, negative 3, and we have negative 3 times 2 square roots of 2. So 2 times negative 3 would be a negative 6, and then it would be minus 3 square roots of 2. Minus 3 square roots of 2. Alright, so once we do that, then we're going to, 8 and negative 6 would be a positive 2, so we have 2 minus 3 square roots of 2. Now, the next step is to multiply this by this, and that's where we get tedious. I'm going to come to the side again like we did a while ago. So we have 2 plus the square root of 2 times 2 minus 3 square roots of 2. 2 times 2 is 4, and 2 times negative 3 would be a negative 6 square roots of 2. We have 2 times the square root of 2, so positive 2 square roots of 2. And then finally we have the square root of 2 times negative 3 square roots of 2, which would be a negative 3, and the square root of 2 times the square root of 2 would be a 2. Negative 3 times 2 would make that a negative 6. So we have a positive 4 and a negative 6, we have negative 2. We have a negative 6 root 2 and a 2 root 2, so we have minus 4 square roots of 2. Alright, so that's what's going to go in our blank right here. We're going to put negative 2 minus 4 square roots of 2. Alright, and when we combine that, you have 10 and a negative 2, so you have 8 minus 4 square roots of 2. And we're going to go one more time. We're going to multiply this times this, and we're keeping our fingers crossed that comes out to be 8 so that we can get a 0. But let's check it out. So we have 2 plus the square root of 2 times 8 minus 4 square roots of 2. So 2 times 8 is 16, and then 2 times negative 4 would be negative 8 square roots of 2. And then we go this way, the square root of 2 times 8 is positive 8 square roots of 2. Right there I got a cancellation. And then we have the square root of 2 times negative 4 square roots of 2. That's negative 4, square root of 2 times the square root of 2 is 2. So negative 4 times 2 would be a negative 8. We have a positive 16 and a negative 8, which gives us 8. So 8 is what goes in the blank, and that would cancel out and become a 0, which we're really happy about. So let's finish writing our factors. So Remember, we went from a cubic to a quadratic, so now we have negative 3x squared. And then that 2 is positive, so we're going to say, these are the coefficients in front of the square term. It's positive, so plus, and we're going to say parentheses 2 minus 3 square roots of 2 with the x in the back. And then again, 8 is positive, so plus, and then parentheses 8 minus 4 square roots of 2. And that is our factors. Those are our factors. And then those are our factors, and so when we substitute or we plug in for x, f of 2 plus the square root of 2, our output, of course, now we know is for sure 0. And so that would be the answer that we're looking for. All right, go Bearcats. Let's keep moving. Let's go to the next problem, which is problem 59. Problem 59 is asking us to find all the factors and list the zeros. So we're going to find the factors and we're going to list the zeros. Okay. This is going to require some, they're going to give us some factors that give us a little hint, which is helpful. The first problem is, all right, so our problem is here. We give us two factors, x minus 5 and x plus 4. I've written those at the top up here because those are part of our total factorization, and I want to have all our factors in there. All right, so we're going to use synthetic division and the solutions to these two factors to divide by to see if we can narrow this down to a quadratic at some point so we can then factor to finish finding all of our factors. So here we go. So that would be a coefficient 1, it'd be a negative 4, it'd be a negative 15, it'd be a positive 58, and a negative 40. And we're going to synthetically divide. And the first thing we're going to divide by would be 5. So you bring down your 1, and 1 times 5 is 5. 5 and a negative 4 would be a 1. 1 times 5 is 5. 5 and negative 15 is negative 10. 5 times negative 10 is negative 50. Negative 50 and 58 would be positive 8. And 5 times 8 is 40. And 40 and negative 40 is 0. So woo-hoo, we got a 0. Now, once you get a 0 and you start synthetically dividing, you've now gone from a quartic to a quintic. I'm sorry, a quintic to a, no, I had that right, quartic to a cubic, sorry. We've gone from a 4th degree polynomial to a 3rd degree polynomial. That would be a better way, easier way to say it. So now we're going to get to use these values right here to synthetically divide. Don't go back to the top. So I'm going to go ahead and keep going. It's kind of like a lower and upper bounds chart format. And so we're going to use this factor, which is x plus 4. So the solution, or the x-intercept, or the 0, would be negative 4. Let's use negative 4. And then we'll get our quadratic and be able to hopefully solve by factoring. So we'd bring this one down. 1 times negative 4 is negative 4, and 1 is negative 3. 4 times negative 4 times negative 3, positive 12. Positive 12 and negative 10 is a positive 2. 2 times negative 4 is negative 8. Negative 8 and positive 8 is 0. So in fact, party guy has a party girl. All right, we're excited. Now, we have reduced this down to a quadratic now. So this would be 1x squared minus 3x and a positive 2. I believe we can finish solving by factoring. You really have to know what you're doing on these problems so that you don't waste time. Otherwise, your test will run too long. So we have an x and an x. Multiply to 2, add to negative 3. I believe that will be a negative 2 and a negative 1. And so that would be the other factors. So x minus 2, x minus 1. I'm not picky at all at the order of your factors. Matter of fact, I would prefer you just putting them in the order that you receive them and then what you find. The x-intercepts for this, or the solutions, would be 5, negative 4, 2, and 1. And that would be the answer to this problem. Hold on. All right, this is problem 64. Same instructions. We're supposed to find all the factors and then list all the zeros. We have two given factors. So I'm going to write at the top the factors for this. And that would be x minus 4 square roots of 3. I have to tell you that really you should know the factors already for this. Because if you have x minus 4 square roots of 3, that's a complex number. You're also going to have x plus 4 square roots of 3. Those are going to become in conjugate pairs, and you should really just be aware of that. So that's something that I'm going to tell you again. You should be aware if you have an x and you have a complex number, x minus 4 square roots of 3, you're going to have its conjugate, which in this case would be x plus 4 square roots of 3, which would save you some time in long division or synthetic division. We're going to do that anyway, just so that you you know that. So I'm going to also go ahead and go x plus 3. And so if you have that knowledge, then you really know that your solutions are also going to be negative, or in this case positive 4 square roots of 3, negative 4 square roots of 3, and a negative 3. And that would be your answer, and we really didn't even do any division, any synthetic division. You could do your synthetic division, find the 0, and then you would have that same answer. So that's just kind of something that it's really not the work or the math that's involved, it's the knowledge, okay? It's the knowledge that you have that would save you some time. All right, have a great night, and I will work on part 2 and maybe post it tonight. If not, I'll keep working on it, and before I leave school tomorrow, I'll have the rest of the review posted, or the rest of the pre-assessment posted. Have a great evening, Bearcats.